Also done is brought in competitors, and it will continue to bring in competitors. This happens to be one of them. A company that is chasing what is very clearly the future of maintenance of the blades and of the towers themselves. So the company itself is SkyRaptor, and it's AI-powered robots. Now, fortunately, I don't have to show you a bunch of videos of the robots cleaning the blades, because you just saw a bunch of videos, great videos by the way, of the robots cleaning the blades. So let me give you a little introduction. Kevin Zhang, who's in the back of the room, is the CEO of the company, and I have to admit, I bow in humility. He's also a medical doctor, an entrepreneur, a serial business starter, and an AI expert. I just happen to be a speaker on robotics and automation, and that's what I do. So I bow in deference to that. The company is in Moorestown, New Jersey. So this is what we're talking about, as if it hasn't become very clear to you. Any version of this, of pitting, that results in this, or less severe than this, obviously. You don't go directly from leading edge problems to a catastrophic failure. So it's everything in between, and then what does it all mean? That's, if I said everything, why are we talking about maintenance? Why are we talking about robotics? It's this. But I'd phrase it in a different way. I believe what this company is doing, what Aerones is doing, and what all of you are doing in this industry, Joseph Campbell would have called a hero's journey. Your enemy is not the other companies doing what they're doing. Your enemy, or the dragon, or the Darth Vader, or whatever you want to call it, the threat to you is the other power generating sources in the world that don't want this one to exist, or want less of this one to exist. So the goal is, how do you compete aggressively and assertively? That's what we're talking about in maintenance. And the way you do that is you have a robust industry of people who know how to make these very, very efficient. So that's what we're going to talk about. What are the challenges? High operational costs. Now, I want to talk a little bit about this. Yesterday I had conversations in the cocktail setup, and some of the people who are actually running these farms are saying, I'm spending all my time on much more severe things. I don't have time to worry about leading edge maintenance or cleaning. Does everyone realize where that goes? If you don't have time now to work on it, it's just a matter of time, right? Until your warranty is completely worn out and you have a huge failure, or water in the plugs the drainage plugs are filled, etc. So high operational costs. Talent shortages. I think personally the future of this industry is robotics working with the people who are up in baskets. If we make it a we-they thing, these incredibly skilled, very high risk-taking people in baskets, if you think it's ever going to be a them or us, it's not. It's going to be great people in baskets doing great things and great robots doing other things. It's that scene from Star Wars where R2-D2 helps them out of the trash compactor. It's a combination to make it work right. So that's the talent shortage challenge. There are only so many people who want to go up 300 feet in the air and do what they have to do. And I saw a training presentation earlier today, how important it is to train these people and how long it takes to do it. Significant safety risks. Has anyone been up on 300 feet off the ground on a rope in a basket? Yeah, raise your hand if you've been in a basket, right? It's terrifying, right? I was once 150 feet up off the ground on the Coast Guard Eagle, and I thought I was roped in. I thought I was clicked into the mast in the middle of a hurricane, no kidding. And I'm pulling in the sail with these other Coast Guard guys, right? And I suddenly look down and realize I am not connected to the mast. Does anyone know what terror feels like? That's what a person 300 feet up in the air feels like. And the other one, of course, is all the inefficient manual processing. But I want to make sure we don't say this. You're bad if you're in a basket. You're good if you run a robot. That is simply not the way it is. The term autonomation, I would like you to think about this term. It was actually originated in Japan. What autonomation means is the combination of what to be automated, because it makes absolute sense what to be automated, and what not to be automated. And the error happens if you don't automate what you should, or you automate what you should not. It's how Toyota kicked the Americans' butt in the auto industry in the 1980s. So remember that. There's a long story behind that, but that's what I think we should be thinking about. So how do we defeat that? Because of course the business impact is revenue, cost, and risk. So it's faster, safer, it's lower cost if you use robots of any form to do the key things you need to do. And now I'd like to introduce you to some of the robots that another company makes. That happens to be SkyRaptor. So the first one, let me go back to, I don't know how to go backwards on this, do I? Yeah, I do. Okay. Right, so this is one of the robots I'm going to take you through in detail. But the overall point, and I heard this yesterday as well, some of the questions, how much of this do you automate? Do you just do cleaning? Do you just do inspection? Do you do internal cleaning, internal inspection, external inspection? What level of repair? Do you go category 1 to 3 or 1 to 5 of the damage? I think the answer to that is as much as you can possibly automate and the ROI generates is positive for you. So what SkyRaptor does is two primary things: blade services and tower services. So what do the blade services include and tower services? Inspection, cleaning, and repair. One company, all three things. I think that is also the future. One company, all three things. So you need to be able to do some degree of all three of these things. So from this, guys hanging, who hangs in a basket for a living right now? Anybody a basket? That's not the way to describe. Who is an incredibly skilled person up 300 feet in the ground? Anybody here? All right, no, so nobody's in the room. But we're going from that, obviously, to much more of this. Minus the right time to put a person in a basket to do the person repair, right? Make sense? Okay, so the current servicing model, 10 hours plus with a basket rope setup, a point-in-time monitoring. Right now you have data, but you don't have it real time. You can't immediately adjust to what you're doing unless it's in the human's mind. It's high risk midair. It's 3 technicians, 3 very expensive, well-paid, wonderfully talented people, and 1 blade per day. What can you do with SkyRaptor? And every one of these numbers you can imagine will only improve, right? So if this is the baseline of what these tools can do now, imagine what the future is. So ask yourself, how much improvement will the manual process do? And will the curve of improvement for manual be able to keep up with the curve of robotics? And I think you know the solution to that. So it's a 1-hour setup, an air-conditioned trailer as opposed to hanging 300 feet off the ground, 2 technicians instead of 3, high-resolution cameras providing all the information you need, real-time data to help you move the tools around where they need to be moved, end-to-end visibility of everything you're working on, and 2 blades per day. Now, remember those numbers, you're going to hear those numbers from whoever. There's a lot of dependencies, right? Maybe at some point we'll get to 3 blades per day. It depends on the speed, but it's faster than a person doing it, and that's the bottom line. All right, so here's the robot family. Like, now I'm going to talk about birds. So let me bring the birds into the room. All right, bird number 1, the owler. I think yesterday you saw a good example of another version of this, where you actually have a robot that can get completely almost to the very end of this blade and find what it needs to find. It can identify exactly where the defects are. It has 6 cameras to capture the information and the detail. It can use sensors to say what's going on, what went on from the last time we were up in this blade. So you can see that is the standard of technology, to be able to do that and to be able to have the pictures that feed the AI models. Okay, caution. When someone says it's AI driven, that's like saying it's on the web, right? Well, yeah, but how easy is it to find, and how good is it, and how clear is it, right? So it's always worth checking. They say an AI model. How good is that AI model? Is it actually predicting what it needs to do? Those are questions you as operators and technicians should all be, and business leaders should all be able to ask. The next one is the LPS test. We all know how critical it is. If the lightning protection systems are not working, what happens? That was that catastrophic. I hate to laugh at a catastrophic example like that. Obviously, here is a robot specifically designed to find any breaks in the line, identify the location, but that location to be fixed properly will probably take someone up to go up and do it now. But in the future, it'll probably be done by a robot, even if it's below the surface. So the next one, the Peregrine and the Osprey. This is a key distinguishing feature, and someone brought it up earlier. It's important, of course, to have a high-speed robot go up and clean these individual blades and clean the tower. But it doesn't want to clean it too abrasively, and it needs to actually form fit to what it's cleaning. Right? So that's very important. You can imagine all the, and I think you all are aware of all these variables. What's the chemical that's being used? What's the amount of friction that's being applied to the surface? How is this cleaning taking place? And are you causing any damage to what you're actually doing? It's really nice, think of a car wash. Would you take your brand new expensive car to one of those car washes that somebody just washed their big ugly dirty truck? Maybe not. So very important, the sensitivity and the form fit of the brushes and how they spin, etc. So Hawk is probably the most common, the most frequent problem that many people are running into, aside from actual damage, and that's, I mean, on the main fiberglass of the actual unit. So Hawk is for leading edge repair. What does Hawk do? This is a key point. In order to make Hawk work, it's on a 6-axis robot, which means it can change tools and rotate in every angle you can possibly want the tool to rotate. Well, every angle I can think of that that the tool would need to go. Very, very important. And as a result of that, you can both repair the surface, analyze the surface, apply the coatings that you need to apply. We saw a great presentation yesterday about a rain coating and all the other kinds of coating. And you can do it either in the spatula mode or in the spray mode. Now you can imagine, we were talking just a few minutes ago about how do you make that final edge smooth when you apply something to the final edge. Part of that is actually having the coating thin as it goes toward the edge. And the next part is having it sanded at the very edge. So that was someone, I don't remember who it was, who specifically asked that question. But that is exactly what Hawk is designed to be able to do, because it's a recognized aerodynamic problem. Okay, Falcon, and this is sort of the big guns. Now what do? It's not just a little dinging on the leading edge. It's not just dirt. It's not just a minor problem. What do you do to actually go in and fix holes, to fix fractures, to do something that will literally require somebody going up? So that is exactly what Falcon is designed to do. And it can actually use the UV activated patches. It puts the coatings over the top of it, all the things that a human being would normally do. However, what if it's a really big problem? What if it's a really big fracture? What if it's something the AI model predicts will lead to catastrophic failure? You're probably not going to send a robot up, right? You're going to actually fix the catastrophic failures. So again, that's the state of the industry, to be able to have these robots predict and do the repair that they can do to a point. But nothing is going to repair right now. Nothing is going to be able to repair the unbelievably large damage that exists. So that's the Falcon. So what does SkyRaptor do as a business? Two things, primary things, or two service models. One is robot as a service. So that is come out and clean the blades and disappear and go off into the sunset. And that's going to work for a lot of people, and it works for a lot of people today. But it won't be long until people bring on board their own technicians, and many people obviously have their own technicians today, but not necessarily their own technicians operating these repair robots. But you can see that's an obvious next step. The ROI would certainly justify bringing on a team if the wind farm justifies it and the cost. So the next piece is robot leasing. So the robots can actually be leased to, not you, you're not necessarily the right people in the room for that, some of you are, but leased to the actual operator and do the work themselves. So it really is flexible as to what works. Of course, if I were operating a large farm, I would test, I would pilot, and then I would decide. And I suspect that any of you who are in the operations mode would do that same thing. So remember what I said earlier. What are the overall points for any of this robotics? Why did we go to drones to do analysis on the exterior, to do exterior damage? Well, all for these kind of reasons. Operational efficiency, the faster repairs, the reduced downtime, the data-driven insights. As an AI person, in that I spend most of my time studying and talking about AI, the quantum leap that is capable now because of what we're doing. I mean, think about people who've been in this industry for 20 years. We were doing all this kind of work before, right, 20 years ago, but you didn't have the data. You didn't have the predictability of what's going on. So those data-driven insights are huge. Obviously, cost savings. It's a lower labor cost. It's minimized revenue loss from outages. Any moment that you can function without, any moment that you can repair and that the plant is up and running, of course, that's great. These robots can operate at a relatively high wind level, which of course is another trade-off we all go through. You get your $350,000 a week crane, it's right on your wind farm, and a sudden shift in weather, and what do? You still pay the $350,000 a week for the crane to be sitting there, I'll tell you that. That's not a free ride. So the most you can push it into the weather envelope, the further you can go into the weather challenges, the better, and the more likelihood you have to get the repairs done. Okay, enhanced safety. I mean, I think that should go without saying. It's not just the person up on the 300 feet off the ground, but think of the insurance costs and all the other. Like, what did we do? We had a moment of silence earlier today. I don't know what the specifics were of the two people who died. I mean, that's what that whole box is all about. I mean, you want to talk about making it real? Think about the families of those two people who were up in the air. So the future clearly is going to include more robotics and a blend with the people that are working with it. And scalability. So as wind farms hopefully continue to proliferate, and there's more support and more endorsement of these things taking place, you need a solution for this. And a solution, again, is that combination of people and the robotics. So, in conclusion, before I get to this slide, I use the metaphor of the hero's journey. And I want to say that again for now. You come to a trade show, and what do you hear? You hear a bunch of vendors. They talk about whatever they talk about, right? Their tools, their coatings, in this case, their technology, their analytical models, some cool weather maps that had all kinds of great colors up there on the screen. I mean, that's all useful and it's all interesting. But is it inspirational? I'm not sure. Depends on how you took it. Here's the inspiration I would ask you to at least consider. You are in an industry that does some amazing things, that has a long list of goods that can take place in the world. You can go to a barbecue or a cocktail party or whatever and talk about what you do in this industry. This industry needs to survive and thrive. And the way it is going to survive and thrive is to continue to compete in an environment that has less and less governmental support. So, how do you do that? This is one of those ways. So, what did I hear this guy talk about and the guy before him talk about? Robots? No. You heard both of us talk about a way to make an industry vibrant, thriving, and competitive in the world. And in a place where everyone's happy to hear you walk in the door and say, I work in the wind farm industry. Wow, that's great. And how did you survive in that industry? We overcame all kinds of obstacles. We got our lightsaber out and we killed Darth Vader, or whatever you had to do to overcome that. And that Darth Vader is inefficiency, technical problems, mechanical issues, people getting injured up in baskets. So we are all on a hero's journey. That call to adventure is take a great industry and make it greater, and make it absolutely bulletproof against the industries that would really like to see you go away. Right? That is what I perceive as the hero's journey. Hopefully you can be equally inspired in your current career and going forward in the industry of winds. And you can come by and see SkyRaptor. So I gave you 3 steps. You can come by our booth, talk to Kevin and myself. You can schedule an exploratory discussion where we can go through the details, and you can get a live demo of the robots. We will not fly you to Latvia. That's what the first company in the industry does. The second company doesn't fly you to Latvia. The company happens to be a US based. So for questions, Kevin's going to join me on stage, and I'll take you to Q&A.
Hello everyone, my name is...
Oh yeah, it's us. The star of the show.
Hello everyone, my name is Kevin Zhang. SkyRaptor based in New Jersey. I would like to take a picture from you.
So questions for Kevin. Not about medicine, please. That was a previous life for him.
Any questions?
Come on, hard questions. What do your robots do and not do? Yes, sir.
Are you all working on core replacement? Is that kind of the next area?
I'm sorry, I couldn't quite hear you.
The core replacement and blade repairs? I haven't really seen that mentioned in
Core replacement?
Yes, definitely. Our robots can replace the core material. The first step is milling. We have automatic AI-driven milling and very accurate, precise milling, and replace the damaged material. Then replace the like a partial work and the core material. Yeah, this is a simple procedure for our robot arm.
I think the answer to that was yes. Other questions?